in the spring, the jack-in-the-box is compressed to a distance of 8 centimeters from its relaxed length and then released. What is the speed of the toy head when the spring returns to its natural length? Assume the mass of the toy head is 50 grams. The spring constant is such the toy head moves only in the vertical direction. Why is that important?
There's no height.
We have to figure out the component that is vertical.
Oh, yeah. There is no.
Okay? Also assume that there's a lot of assumptions here. Disregard the mass of the spring. Okay, a lot of assumptions here. So what? I know there's going to be elastic potential energy Y.
Spring constant.
Spring.
Or spring.
Elastic is the
Spring. Not fall.
Oh my goodness.
Yes.
Okay.
Oh.
There's all of them.
Even though some of it's
No, we write all out.
He's writing it down.
Because that takes a lot of time. Really efficient.
No, there is.
Stop it.
Hey, what?
You just got in my head now. Can I just write below so that some of you who cannot take a photographic memory in your head can understand it?
I hate when I can't take a photograph and camera in my head. I hate it when my internal camera doesn't work. I hate you guys.
You just said you love it.
I love you guys.
Yeah, but he's happy.
We're going to say that in a D way.
We were going to put on your happy face. That was for my 16th birthday, by the way. It was for my decoration.
Okay, you ready? What?
I said,
Hey, men don't have mood swings.
You want to bet?
No, wait.
hormones are the same.
That wasn't a mood swing. That was a joke.
But not nearly as often.
You're wasting so much time.
It's okay, Cheyenne.
No, literally stop talking.
Here we go.
Oh.
Okay, what are some things we know?
We know the distance.
What's X?
It's 0.08. Yeah.
Now, why did I not have to take a number and subtract it from another number to get X?
Because they gave us.
Because they gave me how much it got compressed. So that would be the difference from its relaxed state to its compressed length.
Yes,
Okay? What else do we know?
The mass of the toy head, which is 50.
No, 0.05.
Sorry.
Oh no, it's good.
Yeah, but would I really think that the science of this now
Okay. Let's think of the context of this problem. We got some jack-in-the-box, which is going to be very difficult to draw, so I'm not going to try to draw it. Some compressed spring. Okay, so let's think about the context here. Let's just break it off one part at a time. Okay, you wind a jack-in-the-box, and right before it pops, does it have kinetic energy?
No.
Why?
Because it's not moving.
Because it's not moving. It's right before the spring is engaged, it's not moving.
Oh, there's not going to be gravity. There's no
Okay?
Yeah, no Peggy.
Will it have potential energy to gravity initially?
No.
No. Why?
Because
It's on the
it's on the
ground.
ground.
Okay, we're going to assume that our lowest point is always our zero level. It helps us make the math a whole heck of a lot easier.
So both kinetic energy are
Peggy, zero.
I didn't say both. I didn't say both kinetic
I know,
energy.
but no, but both the boxes will be equal to zero.
What's your question?
Oh, you're thinking, that's right.
We're both potential.
I didn't say, all I said was this and this. I didn't say anything about any other potential energy. I just said potential energy to gravity is zero.
Why is KP zero?
Because it's not moving right before you let go of the spring. Like if I wind up and the spring is getting compressed, and it's compressed, and right before I let it go or it pops, it's at its compressed state and it's not moving. And as soon as I let it go, it's going to go wham, right? Okay? And it's also at its lowest point when you've got your compressed spring. But we're going to set that as our zero level to make this problem a whole heck of a lot easier. Now, we do have elastic potential energy. Why?
Because your
The spring is compressed right now. Okay? will we have kinetic energy final after it's went from its compressed spot to its relaxed spot?
Yes.
So we're gonna have that. Will we have potential energy due to gravity?
No.
Yes.
Yes.
Why? Oh, you're up. Okay.
We're above zero level.
No.
Yes. If we have a compressed spring, and then we have our relaxed spring, and this is our zero level, aren't we a height above zero level?
Yeah.
So the spring, not the box.
Well, it is.
It's in the box, but
But the box is sitting at zero level in the spring.
Yeah, we're worried about the head that is connected to the spring. Yes. Okay? So we have this, we have this, we have this. Do we have elastic final?
Yes.
No,
This-
you're uncompressed.
this-
We are uncompressed, we are relaxed. What does it say?
No, I know that, but
You're like Oscus.
wouldn't that?
The spring returns to its natural uncompressed state. If the spring is not compressed, does it have any potential energy stored up in the spring if it's not compressed?
No. I'm not gonna be able to do this on my own.
So stupid.
Okay.
So now we have a problem.
It's a math problem, actually.
None of them.
So you gotta divide by h to zero that.
They're not like.
Oh, I see. When you solve for
So wait, all,
Wait, I did that wrong.
No, also.
what are you doing?
okay, yeah.
It's
like-
one
It's
half.
one half.
Okay.
Sorry, guys.
Oh, sorry.
That's why we don't use pen.
Yeah, let me do that. I don't use this.
Everyone see what we got so far?
So we can
Yeah.
solve.
If you want to break it up and solve it one part at a time, that's fine. Do you? I'm you. But I'm going to do it all at once.
That's fine.
Okay? So what exactly are we solving for in this problem?
Yeah. Okay, fine, BF squared.
Or I don't even see it. What is the speed
Velocity.
of the toy head when the spring returns? So this would be your VF is what we're solving for. Okay? So let's begin pulling apart the layers of this onion.
Ooh. What? Onions have layers.
Because they make you cry.
Have layers. Cake. Caramel ice cake.
Okay, so I'm going to subtract this, bring it over.
Did I get it right?
So 1/2 kx squared minus mgh final. Oh, should equal 1/2 mvf squared.
That's what we're solving for, VF squared. So then you divide by
Oh, then you divide
0.5
by.
m.
Okay? So we are going to then divide these two.
So wait, would the height final
How do you know what the height final is?
would the height final be the compressed height?
And then square root it.
The height final is going to be this.
Okay.
Because if I said the difference between relaxed and stretched is 0.08 meters,
So,
wouldn't that then be the height above zero level once you got to the relaxed spring length?
so you can get rid of that s to me.
No, it's one by
Let's go well.
What was that?
Wait, you can cancel out that one half.
What we're saying is this is our zero level. Okay? So we know there's no potential energy gravity here. Okay, but we also know that it's 0.08 meters below the relaxed. Okay? So then I'm going to take the square root of everything here
Where are you taking
so that I can get VF by itself without the square.
Kind of about that. Right up on
Now there's nothing else here I can really cancel out because I can't cancel out the halves because this doesn't have a half here. I can't cancel out the masses because there isn't a mass in this part. So we're really just going to have to plug this all in. Shouldn't be a square where?
No, yeah, they did. VF shouldn't be squared, it'll go. Because you took the
Oh,
square
yeah.
root.
Sorry.
How do we know what the height was?
It's 0.08.
You don't know if I.
What do I, where must say this?
Well, think about it.
Good night.
We're saying that our zero level is here. That's what we're saying, right? That's our initial position, is where it's been compressed. Okay? Our final position is when it goes back to its relaxed state. So the difference between our initial position and our final position is really just the difference between relaxed and compressed.
108.
Does that make sense?
X is, and you
You could say height is 0.08 as well.
Yeah,
It's
that's
not always going to be the case, but in this context it is.
I got 2.94. I got it.
Hurry up, that's enough.
I got it.
Alright?
I got it wrong.
Plug in, see what you guys get. See if you
I
guys
got
get
the
this.
wrong answer. I got 2.95. 2.94 actually.
2.94 liters per second.
Oh yeah, that's right.
All the sick fix, please.
Wait, it was gonna just be. 2.94.
Okay.
Is that some inside joke?
No,
There's just always like,
That makes sense to me.
It's not one.
so.
That's such a good.
It's good, man. Patrick Star.
Is it
Your
2.9?
idea. This is your idea. Yep, I found this idea.
Is this your wallet?
This wallet. That makes me think it's your wallet.
That makes sense to me. What is
the
the answer?
answer?
That's not my wallet. That's not my wallet.
Wait, don't say the answer yet.
2.94.
Tickle bells on
It's
it.
like, what's in this box? My wallet.
Emma? Still working?
Yeah, but you can do whatever.
No, Craig.
Jeff, did you get 2.9? 4?
Yeah.
I'll help you with that.
I'm like, no, that's off, right?
Scrub!
I didn't do it your exact way.
Helping. Okay, but how you act affects other people. Okay? Cheyenne, you get it? You get it?
No, you're going too fast.
Yeah!
I got 2.9. Is that right?
Yeah.
And what's
Lauren, got that?
the meters per second squared? Hey, wait.
Emma, were you able to get that?
So all the problems yesterday are just the second?
Not the last one.
Yeah, oh.
Hey, I think that problem that we just did was your first problem in your homework.
Go team.
I thought you
What?
said we weren't doing problems like these.
No, we didn't do the
Hey, guess what?
Why
This
is
is
there-
problem 41 in your homework.
Why is there an
Are
angle?
you serious?
Let's go.
I like Tarzan.
There's an angle on this
I
guy.
see an angle. I see an angle.
Hey, yes
So then
sir.
you just solve the angle on it. You just
The
say,
best part about this is the Tarzan. Okay, so let's say that we've got some tree here. There's my tree.
That's a good
No.
Okay?
There's a bird foot.
There's another tree branch here
oh,
with a vine on it. The vine
6 seconds.
is being held by Tarzan, and on Tarzan is Jane.
Whoa. It's insane.
Okay? This angle is 30 degrees. That's a great problem. Okay? Hold on. At the bottom of the arc, Jane releases.
Wait,
Jane is currently dead.
Bye, Jane.
Wait, where does it say that?
Wait, dude.
Oh, Z. Oh,
Why does it matter?
Because it changes the mass after.
Oh, that's dumb.
Are you vlogging?
Got like an afro.
Chad?
Did you say a stick figure?
So just solve for both of them individually and then do it? You like solve like 2 different problems
I just
essentially.
saw. Why are you so smart?
Okay? So here's what we're going to do. We're going to solve 2 problems here. Initial, final, and then this final spot will be the new initial, and our final will be somewhere up here.
Why do we leave it 30?
Is it going to be on the same level as the first
It's
initial?
not even a try.
It's not even.
That's what we're trying to solve.
There's a double.
What's the number of charge? Is it going to be on the same level as the first initial? Or what do you mean? Like, is it going to be done?
So like we're gonna say our first problem is from here to here,
Yeah.
and then we're gonna take our final velocity here and make it our initial velocity here. Yes.
Will the answer be relative to the bottom or relative to the initial?
Like,
Top of
maximum-
zero level?
Yeah, well, maximum height, will that be relative to the very start of it or the bottom of the swing?
I would say that our zero level is probably going to be
Standing
here.
on
That'd be the 5 meters.
Okay,
Okay, but we have to figure out what our initial height is.
okay.
Okay? Let's talk about first situation here. Now, we're going to assume that this vine does not stretch. Cool?
I'll stretch you.
Cool. So no elastic.
Yep.
No, 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 no.
And there's no kinetic energy initial. So it's Peggy equals K.
Peggy equals calf.
Peggy
I was
equals
literally
K.
like,
In
oh,
most cases.
that's not.
Wait, is there?
There's going to be no kinetic energy initial. Why?
Stand still.
Because we're not, they just are holding on for dear life. They're not jumped out yet.
And they're not gonna have any potential final because they're bottom of the arc.
Okay, we're not going to have any potential energy at the end because we're going to set our zero level to the
Oh, wait.
bottom of.
My favorite part of this chapter is the,
Is all that you have to do with the angle resolve the triangle?
yeah.
No,
Wait.
that big, a lot less work.
It's not that bad.
Kramer,
Yep.
why will you have no potential energy?
Because you're at the zero level.
And the swing.
So wouldn't you get rid of kinetic energy also?
Why?
Because you're at the zero level?
Does zero level have anything to do with kinetic energy?
Well, you just said zero level for the kinetic energy of
No,
initial.
I didn't. I said zero level is the reason why this is zero. The reason why this is zero is because, okay, here's the thing we have to understand. Kinetic energy is 100% based on whether you're moving or not. Because isn't kinetic energy energy in motion?
Yes.
If you're not moving, you have no kinetic energy. If you are moving, you have some kinetic energy. Make sense?
Yeah.
Second, potential energy is all based upon how high you are above the ground or whatever your zero level is set at. Okay? Now, we could say that the ground's way down here and our zero level's way down here, but if we do that, that's going to make this problem a whole heck of a lot more difficult. Okay? Because then we wouldn't be able to cancel that out, and we'd have to do more work, and they'd have to give us more information, and that would just be awful.
Would you do the same answer though or no?
Yeah.
Okay.
Okay? So, we have potential energy to gravity initial because we're above our zero level, and we have kinetic energy final because when we start swinging, are we going to be moving down here? Are we going to have motion?
Yes.
Yes. Now here's the kicker. We're going to be solving for that. We know the masses. We have to figure out what the height is.
So just minus that from the vine and then you go.
Okay? We need to find this here so that we can subtract it from the total length.
Wait, do we have?
Do we know the total length?
We know the vine, don't we? 5 meter vine. So this would be, from here to here would be 5 meters.
So 30.
So once we find this, we can figure out how high we are above the theoretical ground.
I have sine 30.
Yeah, it's
It would be
2.5.
opposite, so yeah, it would be,
2.5.
this is 5 meters, the length of the vine. So it would be 5 sine of 30 should give us our height.
4.33.
4.5.
Do you assume
Five
she
sine
drops
of
off?
30 is
7.
2.5.
Oh, wait,
2.5.
4.33 would be the cosine.
Yeah.
4.33.
That was
I did cosine, my bizzle.
Does she drop off after we solve for the KEF or no?
Before.
So like for the mass for KEF, would that be 130 or?
It would be 130.
Okay.
And then when we set it up for the initial on the next problem, it would be the without Jane.
Yeah, yeah.
She's above that.
And will we have to subtract the James mass from the total mass? since it's
Yeah.
hard?
Yeah. So, technically, the answer here is not the correct answer, but it ends up being the correct answer just because if you take 5 minus 2.5, you still get 2.5. Because we don't want this height, or we don't want that measurement, we want this measurement. It just so happens it's the same.
So
It's still 2.5, but I just want you to know, this doesn't make sense for the height, right? The height is actually from zero level to here.
yeah, so the height is still 2.5.
Yes. Yep. Okay. With this information, you should be able to solve for the F.
Which is 7.
Okay? Yeah, let's not, can we try not to just yell out the answers so that other people are working, we can allow them to still work and try to get the answer.
Wait, is this supposed to be like?
Okay, so here's when you actually plug this in, you will get 7 meters per second. I do not want anybody else saying if they've gotten through the second part of this what the answer is. Okay?
What's the second?
It's your homework. Do it.
What's the
And
second?
keep it to yourself.
What's the second part?
What was that?
What's the second part?
What do you mean what's the second one? What do we have to do to
What's
finish
the
it?
maximum height?
Okay? So you want, your second part is you're going to have your initial conditions and your final conditions. So the only thing I will tell you about the second half of this problem is your final velocity, which is 7, is going to be the initial velocity going from here to here. And you will not have Jane's mass on it. So you have to subtract Jane's mass out because Jane's falling off.
Why do you have meters per second?
And it's done.
Total height.
Well, that's the final answer. We just solved for.
We have to get this so that we can find. Technically, that's not actually part of the answer. We just need that to solve for the answer.
But that's the part that.
Friends, what's 9.81 times 2.5 divided by 0.5? Can you just square root of that?
130 times 9.81 times 2.5 equals 0.5 times 9.81.
Cancel all your math. You're making it more difficult. They're not there.
Yeah, you gotta write out all this stuff here.
Oh, why did I
They, you
put
can fine, you can put it in there, but they're just going to cancel out.
whose master is it?
The end of this first step or the second step? And the second step will only be, so your first problem from here to here, you'll have everyone's mass, the total mass. Okay? Then we drop them off. And we say from here to here, we're just using carbon. We never even did from here to here. This change is dropping off.
Well, it says her mass is.
Would you miss?
Doesn't give you the total mass. Subtract the total mass, change the mass from the total mass, and then you have carbon mass. And you use that for the second step of this problem.
They said, it'll be fun, they said.
I was like, I'm doing my purple.
It's true.
Yeah, I thought physics was gonna be. I am actually.
It's all lovely.
You just don't like the process. You don't like things that don't come
Oh, guys, but I also don't like going
There.
to tests. Still not fully understanding.
And you do just fine typically on those tests.
No, I get F's. I've gotten a 0 on every
Please don't
test.
scare these students. There's no reason to do that. You're freaking out for no reason. What?
F's
What
on
happened?
yes. That's a reason to freak out.
I got one.
Volleyball over here?
I don't think I'll ever get one from Jack.
Well,